For nearly a century, flight has been powered by engines that follow the same fundamental principle. Air is sucked in, compressed, mixed with fuel, and ignited to produce thrust. This is how jet engines work. From the first turbojets of the 1940s to today's massive turbofans like the Rolls-Royce Trent 800, which produces over 100,000 pounds of thrust, all modern aircraft still rely on air-breathing combustion. But even the most powerful jet engines have a hard ceiling. They need oxygen. And above 100,000 feet, the air becomes too thin to support combustion. To go faster, much faster, and to reach near space altitudes, we need something new, something radical. That's where rocket engines come in. In 1967, the X-15 experimental aircraft became the fastest manned aircraft in history, reaching Mach 6.7, a blistering 4,790 miles per hour. It didn't rely on jet engines. Instead, it used rocket propulsion, burning fuel with onboard oxidizers. The X-15 flew to the edge of space, 60 miles high, skimming the boundary between atmosphere and vacuum. But it couldn't cruise, carry passengers, or be reused efficiently. The rocket was powerful, but not sustainable for commercial flight. To bridge the gap between jet engines and rockets, NASA began working on a hybrid concept, the air-breathing rocket. The result was Hyper-X. Hyper-X, later renamed the X-43A, was a radical leap in propulsion. Just 12 feet long, it was designed to shatter all known speed records using a scramjet engine, short for supersonic combustion ramjet. Unlike traditional engines that slow air down before burning it, a scramjet burns fuel in a supersonic airflow, enabling flight at hypersonic speeds, above Mach 5. Here's how it works. A rocket booster carries Hyper-X to about 100,000 feet. Once released, Hyper-X ignites its hydrogen-fueled scramjet, using its forward motion to compress the air and ignite the mixture without any moving parts. The engine has no turbine, no compressor, no fan. It's propulsion in its purest form, riding a shockwave. During its first successful test, Hyper-X achieved Mach 7, over 5,000 miles per hour. The flight lasted only 10 seconds, but it was a historic milestone. It proved that sustained, controllable hypersonic flight was possible without a rocket engine. A full-sized version of Hyper-X could theoretically travel 10,000 miles in under 2 hours, connecting continents at unprecedented speeds. Imagine boarding a hypersonic airliner in Los Angeles and arriving in Sydney before your coffee cools. That's the promise of scramjet technology. But we're not stopping there. At White Sands Missile Range in New Mexico, even more visionary propulsion systems are being tested, technologies that may one day eliminate onboard engines entirely. The most radical among them is a flying saucer-shaped aircraft known as the Lightcraft. Invented by Professor Lake Mirabeau, the Lightcraft is unlike any other flying machine. It doesn't carry fuel. It doesn't have an engine. Instead, it's powered entirely by a ground-based laser. Yes, it flies on a beam of light. The Lightcraft's mirror-polished surface focuses an intense infrared laser beam onto the air beneath the vehicle. The laser instantly heats the air, causing it to explode in a burst of plasma. Each explosion produces thrust, pushing the craft upward, pulse by pulse. At full power, the craft can spin at 6,000 revolutions per minute, stabilizing itself like a spinning top as it rides the laser beam skyward. This concept, once dismissed as science fiction, is now supported by NASA and the U.S. Air Force. In controlled tests, the Lightcraft has lifted off, hovered, and climbed tens of meters using nothing but light. The ultimate vision? A 100-kilowatt laser array that could launch payloads, or even passengers, into low Earth orbit without fuel. The implications are profound. A laser-powered launch system would dramatically reduce the cost of space travel. eliminate explosive propellants, and enable reusable, on-demand space access. It could turn the dream of space tourism and intercontinental flight through suborbital hops into everyday reality. Professor Myrabo envisions a future where passengers walk out of their homes, touch a maglev belt, and float into a waiting light craft. The craft picks up speed, enters a laser boost station, and in 10 seconds reaches escape velocity, disappearing into the night sky with a flash of light. "There goes Frank," someone says, pointing skyward. As poetic as it sounds, the science is very real. The challenges, however, remain formidable. Laser systems must be precisely focused over long distances. Atmospheric interference can scatter or weaken the beam. The craft must be heat-resistant, precisely balanced, and capable of autonomous course correction at hypersonic speeds. But every day, these barriers are being chipped away. These emerging propulsion systems, scramjets, air-breathing rockets, and laser lift, aren't just about speed. They represent a paradigm shift in how we think about flight. Until now, every aircraft has carried its fuel and power on board. These new technologies break that rule. They allow us to design lighter, more efficient, and far more capable craft, unchained from traditional constraints. They also open the door to planetary-scale travel. In the near future, flights from New York to Beijing could take less than an hour. Trips to low Earth orbit might become as routine as boarding a train. The line between airplane and spacecraft will begin to blur and eventually disappear. But with such speed comes new responsibility. How will we regulate hypersonic travel? What happens when an aircraft can cross borders in minutes or reach orbit without detection? These are the geopolitical and ethical questions that the future of aviation must answer. As engineers and scientists continue their quest to master the sky and beyond, we stand at the edge of a new age. The age of true global mobility, where no place on Earth is more than a heartbeat away. In our next and final segment, we'll look even further into the future, to blended wing bodies, spaceplanes, and craft that may one day bend the very laws of physics. Could we one day fly faster than light? Or is there a new, unimaginable horizon waiting beyond space itself? Join us in the concluding chapter of Aircraft of the Future, only on Infinity Beyond.